Hey guys, this is 7.2. We are going to be looking at systems of linear equations with three variables. So first, to determine if an ordered triple, that's what this is called when you see x, y, z, you've got three variables, that's going to be an ordered triple instead of an ordered pair. To determine if that is a solution to the system, you're going to plug in those values for x, y, and z and see if it works for all three equations. It's only a solution if it is true for all three equations. So we'll start with the first one. 6 times x, so we'll plug in 4 for x, 2 for y, and -8 for z. And that has to come out to 2 in order for it to be a solution. So I have 6 times 4 minus 7 times 2 minus 8, and that needs to equal 2. All right, so that one works. But you have to check all three, so let's do the second one. -4 minus 2 plus 3 times -8, and that needs to equal 4. -4 minus 2 plus 3 times -8. -30. So that one comes out to -30, which is obviously not 4. So it does not equal 4. So this is not a solution. It would have to work for all three equations in order to be a solution. All right, now let's learn how to solve a system with three unknowns, or three variables. If there are three equations, the first thing you want to do is eliminate a variable from any two of the equations. You want to eliminate one of the variables from any two of the equations. To do that, you can use either substitution or elimination. So I'm going to choose two equations to start with. Let's do, I'm going to actually label these as equation 1, 2, and 3. So as I do things, you'll know which equation I'm using. So one option I have here is I could take equation 1 and 2 and do elimination with those. So I'm going to take 1 and 2. That is 3x plus 4y minus 2z equals 14, and 2x plus y plus 2z equals -9. Now, to do elimination on this, I actually don't have to multiply by anything because you can see my z's already have the same number with opposite signs. So when I add the two equations together, the z's are going to be eliminated. So that's what I'm going to go for here. This is 5x plus 5y, z's cancel, equals 5. So 5x plus 5y equals 5. Okay, so that was step 1. Eliminate a variable from any two of the equations. So I eliminated the z. Step 2. Eliminate the same variable. So I eliminated z that time. I need to eliminate z again this time from a different pair of equations. So I can't use 1 and 2 again, but I could use 1 and 3 or 2 and 3. And I need to eliminate z. It doesn't matter which two you choose. I'm going to do 1 and 3. So I'm looking at equations 1 and 3. And I'm going to do elimination again on these. I could multiply this equation 3 by 2 to make it to where my z's are going to be eliminated. So that's what I'm going to write here actually. I'm using equation 1 and 2 times equation 3. So equation 1 is 3x plus 4y minus 2z equals 14. And 2 times equation 3 gives me 2x minus 2y plus 2z equals negative 18. All right, now I'm going to add those together to get my z's to eliminate. 5x plus 2y equals negative 4. All right, so now I've got two equations with two variables. And so now with those two equations, we're going to move on to step 3. And we want to eliminate a second variable using the resulting two equations in two variables to obtain an equation with just one variable whose value we can now determine. So basically that was the long way of saying I'm going to take these two equations and I'm going to either do substitution or elimination to solve for one of the variables. It would be easier to do elimination on these two because the 5x is in front of both equations. We have a 5 as a coefficient on both. So I'm going to name this equation 4 and equation 5. And what we're going to do here is equation 4 and negative 1 times equation 5. So equation 4 is 5x plus 5y equals 5. And negative 1 times equation 5 gives me negative 5x minus 2y equals positive 4. Okay, my x's cancel. That's why we did that. So 3y equals 9, which means y equals 3. Y equals 3. Now that's not your final answer. We got to move on to step 4. Find the values of the remaining variables by substitution. Okay, so we're going to substitute that 3 back into either equation 4 or equation 5. I'm going to substitute the 3 back into either of those equations. So I have 5x plus 5 times 3 equals 5. 5x plus 15 equals 5, which means 5x equals negative 10. So x equals negative 2. And then lastly, to find z, we're going to take x and y and plug it back into one of the equations that has all three variables. So one of the original 3 equations. So I'll do 3x, so 3 times negative 2, plus 4y, so 4 times 3, minus 2z equals 14. And I'm going to solve for z. So negative 6 plus 12 minus 2z equals 14. 6 minus 2z equals 14. Subtract the 6. And divide by 2. All right, so I've got all 3 of my variables, and now I'm going to write my answer as an ordered pair. Write the solution as an ordered pair. That's this last step. write the solution of the system as an, ordered triple because we have 3 variables. So x, y, z. That is your solution. That's the point where those 3 lines intersect. Okay, now this one's going to be a little interesting. On this one, we have 2 equations, or it could be 3 equations, but 2 of the equations are the same equation actually. But you're just going to have 2 equations with 3 variables. It's actually impossible to solve an equation, a system of equations that has 3 variables but only 2 equations, right? You have to have at least the number of equations that you have variables. So if you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations. If you had 4 variables, you would need 4 equations in order to actually get a numerical solution. So here's how this is going to work. Just follow along. Step 1, use substitution or elimination to eliminate 1 variable. So same start as when we had 3 equations. So eliminate one of those variables. On this one, you could multiply the second equation by 2, or the first equation by 3 or 4. I'm going to multiply the second one by 2. To get rid of the y there. All right, so then I can add those 2 equations together. I get 7x, my y's cancel, minus 7z equals negative 14. All right, so I've done step 1. I eliminated 1 variable. I eliminated the y. Step 2. Solve for one of the remaining variables, in terms of the other variable. So choose one of those variables to solve for. So I'm going to solve for x. So I'm going to do add the 7z over. 7x equals 7z plus 14. Divide by 7. Divide everything by 7. All right, so x equals z plus 2. And that's as far as I can actually solve for x. I'm not going to be able to get exactly what x is because this is actually a dependent system. There are infinitely many solutions. It just depends. Because there are only 2 equations, we can't actually fully solve. So we're going to have x equals z plus 2. Step 3. Substitute the equation from step 2 into the other equation. So I'm going to substitute this x equals z plus 2 into either one of those original equations. So I'm just going to substitute that into the first equation. So I'm going to have x plus 2y plus z equals 4. And I'm going to substitute this in for x. Because it says x equals, so I substitute it in for x. So then I have z plus 2 plus 2y plus z equals 4. Just replaced that x with z plus 2. Combine like terms. And I'm going to subtract my 2 over. And you want to solve for the third variable. So I already know what x equals. I mean, I know it's in terms of z, but now I want to get y in terms of z as well. So I'm going to subtract 2z. And I'm going to divide by 2. So y equals negative z plus 1. So I've got x equals z plus 2, y equals negative z plus 1, and the z is actually just going to remain z in your ordered triple. So here's how we'll write the solution. X is z plus 2, y is negative z plus 1, and z is just z. So what you did there was you got your solution, your ordered triple, in terms of z. There's only one variable in your solution, and it is z. Now you could have done that using any of the variables. I just happen to choose z. So that's what it looks like if you've only got 2 equations with 3 variables, or if you had 3 equations, but 2 of the equations were dependent on each other. All right, the last thing we're going to do in this set of notes is use the system of equations to model data, which just means we're going to find equations through 3 given points. So we have 3 points, and we want to find the equation that goes through those 3 points. So what you're going to do is you're going to take those 3 points and plug them in for x and y 3 times. So in my first equation, I'm going to plug in 2, 4. Plug in 2 for x and 4 for y. So 4 equals a times x squared, so 2 squared, plus b times 2 plus c. Now plug in negative 1 and positive 1 for x and y. Okay, now plug in the third equation for x and for y. Okay, now I actually can simplify those a little bit. So let's do that. I'm actually going to square the 2. That's 4, so 4a plus 2b plus c. The second equation, negative 1 squared is 1, so that's just a minus b plus c. And then my third, I've got 5 equals negative 2 squared is 4, so 4a minus 2b plus c. All right, so there are your 3 equations. And so now this is just like what we did on number 2 on the front page. We've got 3 equations with 3 variables, and we can solve for the ordered triple, which will give us our a, b, and c, which will then give us our equation. So our goal is to solve for a, b, and c using the same process that we used on number 2. So we'll solve for a, b, and c, and then we can substitute those in to this standard form for the quadratic, and we'll have our equation. All right, so the first thing that we're supposed to do is eliminate one of the variables from 2 of the equations. So why don't we use, I'm going to label these again. This will be my equation 1, 2, 3. I'm going to use equations 1 and 3 because, as you can see, I can already do elimination because I have a positive 2b and a negative 2b. So I'm going to do equation 1 plus equation 3. So it's going to be 4 equals 4a plus 2b plus c And 5 equals 4a minus 2b plus c. So adding those together, I get 9 equals 8a, b's cancel, plus 2c. All right, so I eliminated one of the variables from those two equations. Now I have to choose two other equations to eliminate the same variable. So I need to eliminate b again from either of the other two equations. So I'm going to do equations 1 and 2. If I do equation 1 plus 2 times equation 2, then my b's are going to cancel again. So 4 plus 2b plus c. And I'm doing 2 times equation 2. So that's going to be 2 equals 2a minus 2b plus 2c. So 6 equals 6a plus 3c. All right, now that leaves me with two equations, two variables. You can use substitution or elimination to solve for both of those variables. So looking at it, it looks like substitution might be my better option this time. I'm going to solve for c in the second equation. So I'm going to subtract 6a. I'm going to divide by 3, divide everything by 3. So I chose this one because I noticed everything was divisible by 3. So that's 2 minus 2a. So now I can substitute that in for c over here. So 2 times 2 minus 2a. Okay, combine like terms. I'm going to subtract the 4 over. Combine these two, that gives me 4a. So a equals 5 divided by 4. So I've already figured out what a equals. Now I need to plug that back in to either of my equations to solve for c. So I'm going to substitute it in for a right here. So I have c equals 2 minus 2a. Well, I found out a was 5 over 4. Okay, in my calculator, you can do that. 2 minus 2 times 5 divided by 4. So I got negative 1/2 for c. All right, and the last thing that we need to do is figure out what b equals. So I actually am going to just shift this up so I can make room to figure out b. Okay, so now I'm going to plug in my a, which was 5/4, and my c, negative 1/2. I'm going to plug those in to either of my 1 through 3 equations here. So I'm going to choose equation 2, looks easy. So 1 equals a, which was 5 over 4, minus b plus 1/2, negative 1/2, my c, so minus 1/2. And I'm going to solve for b. So I've got 5/4 minus 1/2. So that's 3/4. Subtract the 3/4 over, that gives you 1/4 equals negative b, so b equals negative 1/4. All right, so now I've got all three variables. I'm not trying to find an ordered triple here, I'm actually trying to write an equation. So I just need to plug those a, b, and c into this standard form. Y equals ax squared plus bx plus c. So y equals 5/4 x squared plus negative 1/4 x, so just minus 1/4 x plus c, so minus 1/2. So that is the equation that goes through those 3 points.